During this video, we'll introduce to you some picoPower features that let you save power without sacrificing functionality. As an example application, we're going to use the Parrot. The Parrot is an example data logger type of application that lets you record audio and then play it back again. The Parrot runs on an AVR XMega device and uses the ADC to sample input data from the microphone, which is stored in external SD-RAM. Data can then be read back from the SD-RAM through the DAC to have the Parrot repeat what you recorded. Okay, let's verify that it works. Reduce power consumption without sacrificing functionality. Reduce power consumption without sacrificing functionality. Now, there are several ways to implement something like this. First, let's look at a straightforward or classic solution. The classic solution involves the setup phase and then 4 main states reported over and over for the entire recording. First, the ADC does a single sample conversion. Next, the sample is stored to SD-RAM. Then we update our sample counter, and finally a timer waits until it's time to get the next sample from the ADC. The timer generates an interrupt and the next sample from the ADC is triggered by software, and so on. In this example, we'll sample at 8 kilosamples per second and the CPU clock is set to 2 MHz. The activity curve shows how the device jumps back and forth between active and idle modes throughout the entire recording period. Most of this is handled by software, so the CPU spends a lot of time in active mode. The only idle state is the wait state. This of course impacts the power consumption. Also, the CPU is mostly busy here and not available to do other things. Let's try a different approach. The application states are the same, but this time let's use the event system to trigger the ADC when the timer says so, send a sample to SD-RAM with DMA, which also automatically updates the sample counter, and finally wait for the timer to trigger the next sample. Now, the device is in active mode only when initiating the whole recording cycle. All the time in between, the device stays in idle mode, meaning the CPU is not used. Now, compare the two activity curves. As you can see, using the event system and the DMA has quite an impact on the power consumption and also leaves the CPU free for other tasks. In this example, with the CPU clock at 2 MHz, the power consumption for the XMega device has been reduced by a factor of more than 1.2. The XMega being designed for high system performance, let's see what happens if we push the data throughput a little further. Let's increase the sampling rate from 8 to 48 kilosamples per second. To do this the classic way, we would have to run the CPU at 12 MHz, increasing the power consumption. But the event-driven solution with DMA can still do the job on a 2 MHz CPU clock because the entire recording runs in idle mode. Further, we're doing single conversions, so the ADC itself runs at the same speed in every example and the current consumption is roughly the same, even though the sampling rate is 6 times higher. In this case, the power consumption is reduced by a factor of more than 2.6, which shows how the XMega really excels at high data throughput situations. Hopefully, this little example has demonstrated the potential of two of the XMega's picoPower features, the event system and the DMA. Thanks for watching and stay tuned. Thanks for watching and stay tuned.